So today we are looking into logarithmic functions. And were you guys able to find this inverse? You switch the x and y, and you solve for y. So you got x minus 4 divided by 3 is the inverse.
Yeah, 1/3.
That was really
Okay. So 1/3 x minus 4/3, yes. That is the inverse of this function. Now, a logarithmic function is the inverse of an exponential function. Instead of highlighting it, looks like it's, there we go. Logarithmic is the inverse of an exponential. So on all those problems where we were trying to solve for the exponent, it would be so much nicer if we had a way. And using logarithms is our way. So what we're going to talk about is basically the basis, what this is built around and how we define it. Let b and y be positive numbers. This should not say y. I changed this and then I didn't change that. That should say a. Let b and a be positive numbers. Well, b is not equal to 1. The log of, this should say a, with a base b, is a log base b of a. So, this is a logarithm. But we'll just call it log. Log means logarithm. So the way this is read, we read it log base b of a equals x. Log, this is your base, of a equals x. If and only if, IFF, if and only if, the base raised to the exponent equals the answer. So do you see how these switch? Log base answer equals exponent. A logarithm solves for the exponent. So when you need to solve for an exponent, you will use a logarithm because a logarithm solves for the exponent. Now what we have here is an exponential form of an equation. 2 to the third equals 8. Is that true?
Yes.
Yes. If we were to write it in logarithmic form, it would be log. What is our base in this equation? 2. What is the answer part?
8.
8. And it always, a logarithm always equals the exponent. What was the exponent? 3. These are equivalent expressions, equations, not expressions. Okay. So this says log base 3 of 81 equals 4. What is my base in this expression? 3. What is my exponent? 4. Equals, what is the answer? 81.
Is this all we're doing today?
We are learning how to deal with logs. Yes. Now you try these. Switch this logarithmic form to exponential form. Switch this exponential form to logarithmic form. Okay, so number 1, my base is 5, my exponent is 2, and my answer is 25. Number 2, it asks me to switch to logarithmic form, so it is log. When you write your base, you write it as a subscript. What is the base in this case? 4. What is the answer part? 64 equals the exponent, 3. So when we write this, the only thing that should be lower is the subscript, is that 4. Everything else should be sitting on the line. Does that make sense? All right. Now, we have 2 special laws. Because we operate in a base 10 system, our number system is on base 10s, right? 10 to the 0 is our ones place. 10 to the first power is our tens place. 10 to the second power is our hundreds, right? Our number system is base 10. So when we have logarithms in base 10, they are called common logs. And because our number system is based in base 10, and we consider it the common log, we kind of have a shortcut. If there is no base written, it means base 10.
Is that like
Now,
notation? Is that anywhere near
no, it would just mean if I had log of 100 equals 2, we would know this is base 10. 10 squared equals 100. So if there is no base written, it is assumed to be 10. It is the common log. Okay, now, we do have a log button on our calculator. And that log button on the calculator is evaluating in base 10. Which is rather nice. Okay, so let's look at these 3 here. These are all common logs because there's no base given for any of these. So if we were to switch to exponential form, this would be 10 squared equals 100. Of course, the exact one I picked over here. What would this one be? 10 to the first equals 10. What would this one be?
10 to the negative
10 to the negative 4th equals 1 10,000. Okay, any questions about the common log? Okay, here it asks us to rewrite these in log form. So when it's base 10, I just write log of the answer equals the exponent. When it's base 10, I just write log of the answer equals the exponent. Could I not also write this as 0.01?
Yes.
Yeah. Okay, and this one, it would become log of 100,000 equals what? Okay, so we've seen over and over again that the answer to a logarithm is the exponent. A log equals the exponent. So if you were asked to evaluate a logarithm, what we're doing is we're finding the exponent. We know that this logarithm is equal to the exponent. So it becomes 9 to the x equals 6,561. What could I do? I could rewrite this using like basis, couldn't I? This becomes 9 to the what power?
4.
So x equals 4. Okay, on this one, we'll set it equal to x. Okay, so this becomes 5 to the x equals 0.2. Can I write these as a like base? Isn't this though the same as 2/10? Isn't that how I'd read that? 2/10? What does 2/10 reduce to? 1/5. So this is really 5 to the x equals 1/5. So it's 5 to the x equals 5 to the -1. X is -1. Does that make sense? Okay, so there's lots of different things that can be seen. We can evaluate, or we can have things that are, I'm going to cut these because it's too blue. You like this? You think it's easy? That's awesome. Okay. So, some of these you guys aren't even going to have to go equals x. Some of them you guys will be able to look at and go, obviously there are 4 zeros, my answer is 4. Some of you aren't there yet. So those of you that aren't there yet, switch forms. 10 to the x equals 10,000. Well, how do I get 4 zeros? It's 10 to the 4th. So some of you may need to show this. Some of you may be able to look at it and go, oh, what power do I raise 4 to get 64? 3. And you're done. Others of you will still need to say, okay, 4 to the x equals 64. Ooh, that's 4 to the 3rd. So obviously x is 3. Okay, what do you think about this one?
0.
You are right. It is 0. That's awesome. If we set it equal to x and we set it up like this, what power can we raise any number to and get 0?
1.
Except 0 to the 0, which is
0.
indeterminate. All right, so it's going to be 0. 0. Okay? Can you look at this one and give me the answer? -2. Awesome. If you can't, keep doing this. And after you do this for a while, then all of a sudden, it's just going to click. And you're going to go, oh. And then you'll have a little happy dance.
Can we finish this tonight, or do you want us to finish it tomorrow in class?
The back side, you're going to do tomorrow in class.
So we can't do it tonight.
If you choose to do it tonight, then make sure you bring something to do in class tomorrow so that you don't disrupt those around you from doing what I've asked them to do. I don't think sleeping is really an option. We'll go with something academic.
Evaluate the backs of my eyelids.
What is it called?
I have to sleep.
Looking at the veins.
No, this is legit.
Oh, y'all crack me up. Sometimes you just so much remind me of my own children. Like, my daughter argues everything. And I told her that the other day. I'm like, you argue everything. You have another way to do everything. And that's what she said. She went, no, I don't. And I just smiled. And I went, case in point. And she went, oh.
I do too.
All right.
I do too. Your dog usually, I think it was like,
It's okay. I mean, y'all are supposed to. You're figuring out life right now. You're supposed to ask a lot of questions. As long as you do it in a respectful way, it's perfect. All right, here we go. This becomes This is our exponent. So it becomes n to the negative second equals 100. What is n, guys? 10. This becomes, how would I rewrite this? 2 to the fifth equals n. So what is n?
25.
Right in.
Oh, wait, what's this?
32.
That's worse than mine.
That's okay. The sun shines out, I understand. Alright, so this one, what base is it?
10.
10. So 10 to the n equals 1,000.
10 to the third.
What is n? 3. Okay, you try the rest of them on your own.
Do we only have to find n, or do we have to write in an exponential?
You only have to find n, so if you can do it in your head, that's fine.
Oh, nice. It says do both, so do you just want us to do